In 1905, Einstein proposed the mass energy equation. Among them, c refers to the speed of light, a very large number, and it is the square. Even elementary school students can feel it. This formula reveals an extremely huge energy, which is nuclear energy. Proposition of the mass energy equation laid the foundation for later nuclear energy research. Picture, Wiki. People believe that nuclear fusion will open the era of unlimited energy in the future, but we can only use nuclear fission to generate electricity. Nuclear energy has been developed for less than 70 years and has already accounted for 10% of the world's electricity sources. Generating electricity from nuclear fission. It is like opening the door to a new world in the field of power generation. By the end of 2022, China will have 55 nuclear power plants in operation, accounting for 4.98% of the country's power generation, and China's nuclear power capacity under construction has been the world's largest for many years, and our nuclear power will continue to increase. But at the same time, our uranium is completely insufficient. Build so many nuclear power plants. Uranium is not enough. Reminder, our bureau has an energy discussion group. If your career is related to energy, or you are a deep energy enthusiast, don't miss the way to join the group at the end of the article. Versatile but scarce. Uranium is the key raw material for nuclear fission. When 1 kilogram of uranium-235 is completely fissioned, it will lose about 0.09% of its mass, and the energy released is equivalent to burning 2,700 tons of high-quality coal. It is the absolute main fuel of global nuclear power. China's imports of uranium resources maintained at a high level for many years. In addition to generating electricity, uranium is also widely used in various military and civilian fields. For example, the uranium nuclear reactors of aircraft carriers and submarines, atomic bombs, and hydrogen bombs are inseparable from uranium. Depleted uranium, a byproduct of the uranium enrichment process, can also be used to produce depleted uranium bombs and high-strength armor. August 1945. Atomic bomb codenamed Little Boy detonated over Hiroshima. Hiroshima city will soon be reduced to scorching flames. Picture, nationalmuseum.af.mil. Armor-piercing projectiles made of metals such as depleted uranium and a small amount of molybdenum is one of the main anti-tank weapons. Picture, Wired 3. For another example, uranium can be used in agricultural radiation breeding, production of artificial elements, radiation therapy, and imaging diagnosis. This further magnifies the consumption of uranium. Since the 1990s, uranium resources are in short supply. Changes in global uranium resources from 2019 to 2021. Uranium resources are slowly being consumed. According to the 2021 estimates of the UN's International Atomic Energy Agency, IAEA, and the Nuclear Energy Agency's Atomic Energy Commission, NEA, China's uranium demand in that year was as high as 9,500 tons, but its own production was only 1,800 tons. Obviously, China's own uranium alone is not enough. In 2021, China imported more than 13,000 tons, 13,613.9 tons, of uranium resources, U-308, containing 84.8% uranium, with an import value of $1.31 billion. This number will continue to expand in the future. In fact, not only China is short of uranium, but most industrial countries in the world are short of uranium. The exploration, mining, and purification of this highly sensitive and scarce strategic resource are very difficult. Kashiwazaki-Kariwa Nuclear Power Plant, Japan. Once the largest nuclear power plant in the world. Closed due to multiple nuclear leak hazards. Picture, Flickr. First, the content of uranium on the Earth is very low. On average, there are only 2.7 grams of uranium per ton of crustal material, which is equivalent to 0.00027%. According to China's current regulations, the minimum industrial grade of uranium is 0.05%, that is to say, uranium must be enriched by 185 times to form usable uranium ore. If a rich ore with a grade greater than or equal to 0.3% is to be formed, it must be enriched 1,110 times. Review your high school chemistry knowledge. Uranium can be found as element number 92 in the periodic table. In the 7th cycle of group IIIB, the actinides, block F. Picture, Shutterstock. Currently known uranium-containing ores mainly include pitchblende, U3O8, crystalline uranium ore, UO2, uranet, uranium silicate, and uranium black, uranium and thorium oxide. Distribution is very uneven. Uranium minerals in nature. Under its beautiful appearance, hides the deadliest radioactive material. Picture, Wiki and MyDat. For example, Australia's reserves account for 25% of the world's reserves, while China only accounts for 4%. Horizontal screen, find out the distribution of uranium deposits in the world. Mining cost. However, the cost of different uranium mines varies greatly. Internationally, uranium mines are divided into two categories according to the mining cost. Uranium mines with a cost of 80 to 260 US dollars per kilogram belong to high mining cost uranium mines. Australian uranium mines are based on this species based. The uranium mines with a cost of 40 to 80 US dollars or even lower belong to the low mining cost uranium mines, and Kazakhstan, 40.51%, Canada, 17.16%, and Brazil, 11.9%, together account for 2/3. China's uranium resources are also dominated by this kind. Above, reliable uranium deposits of countries representing the world. Bottom, estimated uranium deposits by representative countries around the world. As of January 2021, IAEA. Difficult to purify but in short supply. Whether it is high cost or low cost uranium ore, the cost is much higher than the iron and copper we have introduced before. On the one hand, this is due to the scarcity of reserves, and on the other hand, it is difficult to extract. Ordinary metal ore, such as copper ore, as long as the ore is crushed, the copper can be extracted through flotation to obtain copper concentrate powder for smelting. And compared to the mining of common metals such as copper ore, the history of large-scale mining of uranium is relatively short. The technology for extracting uranium ore is relatively immature. Copper ore leaching pile and storage tank picture, Shutterstock. However, uranium mining is much more complicated. If the traditional method similar to other metal minerals is used, after the mined uranium ore is ground into fine powder, it is necessary to extract uranium from the ore through chemical or physical methods, such as leaching or ion exchange. Concentrate. The main ingredients are 3-uranium octoxide and sodium diuranate, which is the famous yellow cake. Currently, almost all countries that mine uranium produce yellow cake. But yellow cake can't be used directly in nuclear reactors. Used to enrich uranium. Picture, Flitter at Nuclear Regulatory Commission. The other is the in situ uranium leaching method, which has developed rapidly in recent years. Chemical agents are injected into the ore belt from surface drilling, and chemical reactions are used to selectively dissolve uranium in the ore, and the leaching solution is extracted from the surface. The results are also yellow cake. Model diagram of in situ uranium leaching method. Use chemical reagents to dissolve uranium and extract the leaching solution. The brown vat in operation Red Sea is the yellow cake. Mainly 238U, the radiation is much lower than that of enriched uranium. At this point, uranium is about to enter a critical link, separation. The uranium in uranium concentrate actually contains 3 natural isotopes, uranium-234, uranium-235 and uranium-238, which must be separated one by one. Among them, only uranium-235 is the only naturally occurring fissile nuclide on the Earth, and it is the absolute main fuel of nuclear power plants, but its content in uranium resources is extremely low, only 0.71%. The non-fissile uranium-238 accounts for 99.2%. Therefore, uranium concentrate needs isotope separation to make enriched uranium with different purity ratios before it can be used as nuclear fuel. Nuclear fission of uranium-235. Slow, low energy, neutrons split the nucleus of uranium-235 into 2 new nuclei. Also produces energy and neutrons. These newly created neutrons hit other uranium-235 atoms, thus forming a chain reaction. Krypton and barium are used as examples in the picture, Britannica. Specifically, the yellow cake is converted into uranium hexafluoride, UF6, which is sent to a high-speed spinning centrifuge to separate the lighter uranium-235 from the heavier uranium-238. The enriched UF6 gas is converted back into solid uranium oxide, which can be used to create fuel rods for use in nuclear reactors. A cascade of gas centrifuges for the production of enriched uranium in an enrichment plant. Picture, energy.gov. Among them, the content of uranium-235 is very important. If it reaches 3%-5%, it is low enriched uranium, which can be used in nuclear power. 80% is high enriched uranium, and more than 90% is weapon-grade high enrichment uranium. Highly enriched uranium billets recovered from waste processed at U.S. plants. Picture, M. In short, there are many technical barriers to uranium exploration, mining, and purification, and the cost is very high. Our country used to have a very low starting point, but for the sake of national defense and energy security, we can only bite the bullet. In the 1950s, China began to explore uranium deposits. At that time, it focused on granite-type and volcanic-type uranium deposits, and the exploration scope was concentrated in Jiangxi, Hunan, Guangdong, and Guangxi. In 1943, geologist Nan Yanzan went to Guangxi to conduct a mineral geological survey. The presence of uranium minerals was discovered. Picture, the great nuclear industry. In 1958, the construction of the 711 mine located in Chenzhou, Hunan began. Mine 711 is the first large-scale uranium mine in China. A total of more than 4 million tons of uranium ore were mined. Picture, the great nuclear industry. In 1991, the Qinshan nuclear power plant was connected to the grid for power generation, which opened the history of civil nuclear power in China. Since then, domestic demand for uranium resources has risen rapidly, and investment in uranium exploration has also increased year by year. Qinshan nuclear power plant in Han County, Zhejiang Province. Since its construction in 1991, it has been in safe operation for 31 years. Its current service life has been extended to 2041. Picture, onepicture.com. The ore deposits explored during this period were mainly sandstone-type uranium deposits, mainly developed in the basins in northern China, such as the Ili Basin, Zhenggar Basin, Ordos Basin, and Songliao Basin. From 2000 to 2018, new uranium resources were discovered in Ili, Ordos, Erlan Basin, and Songliao Basin. As of January 2021, China's proven uranium resources are about 330,000 tons, including 150,000 tons of credible reserves and 180,000 tons of inferred reserves, but it is still too little to meet our annual demand of nearly 10,000 tons. Hongping schematic diagram of the distribution of sandstone-type uranium deposits in northern China. Sandstone-type uranium deposits are currently important types of uranium deposits. My country will need more uranium in the future. China's current demand gap is mainly in nuclear power. The total installed capacity of nuclear power plants has nearly doubled from 2015 to 2022, from 30 million kilowatts to nearly 57 million kilowatts, and the consumption of uranium in 2021, 9,563 tons, will account for more than 15% of the world. Ever-expanding installed capacity. It also corresponds to the increasing demand for uranium. However, our base is too large after all. Compared with developed countries, the proportion of nuclear power in China is still very low. Horizontal screen global distribution of nuclear power plants. Compared with developed countries such as Europe and the United States, the number of nuclear power plants in China is still relatively small. Construction of nuclear power plants in major countries in the world. In comparison, the construction of nuclear power plants in my country is relatively late. But the construction speed and loading capacity are remarkable. In 10 countries such as France, Slovakia, and Ukraine, nuclear power accounts for more than 30% of their power generation. France is more than 70%, while China has just reached 5%. This ratio is far from changing the current energy structure dominated by coal power. The development of nuclear energy still has a long way to go. Compared with coal power with higher carbon emissions and less stable renewable energy, nuclear power is efficient, clean and stable. Under today's dual carbon goals, nuclear power, as a clean energy, has great strategic significance. It goes without saying. Taking 2021 as an example, the accumulative power generation of my country's operating nuclear power units is 407.141 billion kilowatt-hour, which is equivalent to reducing the burning of standard coal by 115.5805 million tons and reducing the emission of carbon dioxide by 302.8209 million tons. Green water and green mountains are mountains of gold and silver. The development of nuclear power is an inevitable trend to realize sustainable development. Picture of Shenzhen Diabei Nuclear Power Plant, Zhejiang Creative. In late March of this year, the National Development and Reform Commission and the National Energy Administration announced the 14th Five-Year Plan Modern Energy System Plan, which mentioned that by 2025, the installed capacity of nuclear power operation will reach about 70 million kilowatts. The IAEA and NEA predict that by 2030 and 2040, China's demand for uranium will be as high as 22,600 tons and 43,400 tons. In fact, not only China. Some developed countries also have the problem of large demand for uranium and small production. In the face of these two figures, our annual output of 1,800 tons is simply a drop in the bucket, which means that we have to increase imports. The current main sources of imports include Kazakhstan, Namibia, Uzbekistan, and Russia. In 2019, more than half of Kazakhstan's uranium production was sold to China, reaching more than 13,000 tons. If we can stabilize these major sources and develop new sources, the future supply of uranium is still very secure. Our northwestern neighbor Kazakhstan. Really rich uranium. Kazakhstan is the world's largest uranium producer. In 2022 alone, the country will have mined about 16,000 tons of uranium. Inkai uranium mine map in Kazakhstan, Wiki. Of course, if controlled nuclear fusion and thorium-based reactors can be used to generate electricity in large quantities in the future, we can get rid of our dependence on uranium, but before that, uranium is still irreplaceable.